There is a silent operator lurking in the cold shadows of the universe which does not emit light and does not reflect it. This invisible giant makes up 6 times more of the cosmos than the regular matter which forms the stars and the planets and even our own bodies. Our most advanced telescopes cannot see it, and our most sensitive instruments have failed to touch it for almost a century. We are living in a universe where the vast majority of everything is missing, and we have simply called this mystery dark matter. Welcome to all the viewers of the channel. This is space. Today we are diving into a cosmic cold case that has baffled the greatest minds for 90 years. Before we go deeper into the void, please make sure to subscribe to our channel and leave a comment below about what you think is hidden in the dark parts of space. Your support helps us continue our journey to the edge of the known universe. For decades, we have assumed that dark matter is fundamental to our models of reality, yet we have remained without a single clue as to its true identity. Physicists across the globe are using state-of-the-art particle accelerators and underground laboratories buried miles beneath the surface of the Earth in an attempt to detect a direct signal. They have met with zero success until now. In November of the year 2025, a scientific paper was published that sent shockwaves through the community of astronomers. While searching through 15 years of old data from the Fermi telescope, a researcher may have finally captured a glimpse of a telltale signature coming from inside the Milky Way galaxy. This signal is like a ghost appearing in a crowded room. It tells us that something is happening in the heart of our home galaxy that we cannot explain with ordinary physics. We have to ask ourselves if this is the moment when the veil is finally lifted. To understand why this is such a monumental discovery, we must look back at the origins of this mystery and the man who first dared to suggest that the universe is not what it seems. The story begins with Fritz Zwicky, who was a Swiss astronomer born in the year 1898. He spent most of his life working at the California Institute of Technology in the United States of America. Zwicky was known for having a very eccentric personality, but his biggest legacies were his massive discoveries. He was a pioneer in the study of cosmic rays, and he was the one who coined the term supernova. Over his long career, he published hundreds of papers on a wide array of astronomical subjects, but he is best remembered as the father of dark matter. In the year 1933, when he was 35 years old, Zwicky was measuring the red shift of galaxies using the Mount Wilson telescope. This was the same instrument that Edwin Hubble had used to prove the expansion of the universe just a few years earlier. Red shift is a phenomenon where the light from a distant object is stretched as it travels through space. The more the light is stretched, the longer the wavelength becomes, and the redder the light appears to our eyes. This change in color indicates that the source is moving away from us at high speeds. Zwicky focused his attention on a small patch of the sky in the constellation of Coma Berenices, which is near the North Pole of the Milky Way. He spotted something incredible and terrifying at the same time. The galaxies within the Coma cluster were traveling at speeds that seemed impossible according to the accepted laws of physics. He sat at his desk and began to calculate the difference in velocities between 8 of these galaxies. He found that they were moving at more than 2,000 kilometers per second. These galaxies were traveling so fast that the cluster should have ripped itself apart millions of years ago. The gravitational pull of the visible stars and the gas within the cluster was not strong enough to hold everything together. Zwicky realized that the system needed around 10 times more mass than what he could see just to stay in one piece. He concluded that something more must be at work. There had to be something dark enough to be concealed from view, lurking deep within the cluster to anchor these galaxies in their orbits. This was the birth of the concept of dark matter. The question of the true identity of dark matter has continued to plague the minds of cosmologists for over 90 years since the study of Zwicky. It is called dark matter because of its very nature. It is a substance that does not interact with light in any way. This is a massive problem for us because light is the primary tool we use to probe the universe and understand how it works. From the smallest particles to the largest structures, dark matter does not emit light and it does not reflect it. It does not even absorb light to cast a shadow, which makes it truly invisible. We are forced to observe its ghostly effect on objects that are visible to us in order to perceive its presence. We know it is there because it exerts a gravitational force on the stars, but we do not know what it is made of. The two leading theories today involve particles called weakly interacting massive particles, or WIMPs, and other tiny particles called axions. We have not found hard evidence for either of them until the end of the year 2025. At the University of Tokyo, an astrophysicist named Dr. Tomonori Totani found a signal that had never been identified before. This signal was emanating from the Milky Way, and it appeared to have the properties produced by the annihilation of WIMPs. If this is true, it would be the first observational evidence of dark matter in history. To understand this discovery, we need to understand what a WIMP actually is. These are a class of particles predicted to exist by an extension of the standard model of physics known as supersymmetry. They are called weakly interacting because they do not feel the electromagnetic force. They pass through solid walls and through our own bodies as if we were not even there. They only interact through gravity and the weak nuclear force, which makes them almost impossible to catch. However, there is one way we might see them, and that is through a process called annihilation. In the standard model, every particle has an antiparticle pair. When a particle meets its antiparticle, they cancel each other out and release a burst of radiation, often in the form of gamma rays. Gamma rays are the most energetic form of light in the universe. They are like fingerprints left at a crime scene. They tell astronomers where high energy activity is happening and where it might be important to take a closer look. However, gamma rays can be created by many things, such as black holes or dying stars. This creates a serious issue for anyone looking for dark matter. How can we detect the true signal of dark matter in such a chaotic environment? It takes a very painstaking approach to find the answer. In early 2024, Dr. Totani began digging through the enormous back catalog of the Fermi telescope. This piece of hardware was designed to spot gamma ray bursts in distant galaxies. By scraping 15 years of data, he was able to remove the known sources of gamma rays one by one. This is like trying to hear a whisper in the middle of a loud concert. You have to filter out all the noise before you can hear the secret message. We invite you to take a moment to subscribe to This is Space if you have not done so yet. Please leave a comment about your favorite space mystery. Your engagement is what keeps this channel alive and allows us to explore these deep mysteries together. Now we continue our search for the hidden mass of the galaxy. The Milky Way is a spiral galaxy, which is flat and wide like a disk. Most of the visible matter is concentrated in the galactic plane, where the stars and the planets live. This is where we find our supermassive black hole and the majority of high-energy radiation. However, the movement of gas around the galaxy indicates that dark matter has a different shape. It is not flat like a disk, but instead it forms a giant sphere around the galaxy, which astronomers call the halo. When Dr. Totani removed the blinding light of the galactic center, he was left with a unique pattern of gamma rays. This pattern had the ghostly shape of the predicted dark matter halo. It was not just a random cloud of energy. It matched the mathematical models perfectly. Even more exciting was the energy spectrum of these gamma rays. They were peaking at 20 giga-electron-volts, which is exactly the range we would expect if WIMPs were crashing into each other and annihilating. If this signal is indeed from the annihilation of dark matter, it will change the face of physics forever. It would mean that we have finally seen the face of the invisible giant that has been hiding from us for so long. But before we can be absolutely sure, there are still a few puzzling parts of this case to solve. We are still trying to figure out exactly how much mass these particles have. They are still theoretical, and we are working with a wide range of possibilities. There are also concerns about the density of these particles. The signal discovered by Dr. Totani seems to come from a much denser collection of particles than what our current models of the early universe suggest. We know from studying the cosmic microwave background that there should be a certain number of particles in the universe. If the signal is too strong, it might mean that our understanding of the Big Bang needs to be updated. This is why many scientists are still being very cautious. Professor Carlos Frank, who is a lifetime researcher of dark matter, has compared this discovery to the theory of evolution by Charles Darwin. It is not something you claim to have found unless you are absolutely sure. Scientists are now working to untangle the details of the signal to see if there is any other explanation. One thing is for sure, though. The more we discover at the edge of quantum physics and the vast expanse of cosmology, the closer we get to solving the biggest mystery of the universe. Is this enough to lay the cold case to rest? Unfortunately, it is not over yet. While this is brilliant new evidence, it is just the beginning of a new chapter. We need to see similar signals in other galaxies to be sure that this is a universal law and not just a local anomaly. If WIMPs are real, we should see them in our neighbor galaxies as well. This is where the next generation of investigators comes into the picture. The latest investigator on the scene is the Vera Rubin Observatory in the country of Chile. This facility is named after Vera Rubin, who was a prolific researcher in the 1970s. She discovered the effect of dark matter on the speeds of stars in over 60 different galaxies. Her work was a pivotal moment in convincing the scientific community that dark matter was a real thing that deserved study. The observatory named in her honor came online in June of the year 2025. This observatory is a monster of technology. It takes hundreds of images of the southern sky every night, which results in 20 terabytes of data. That is the equivalent of 78 standard mobile phones every single night. By the end of its first 10-year survey, the raw image data will add up to more than 60 petabytes. This is a massive effort to reveal the secrets of our universe and finally find the source of the missing mass. Dark matter makes up more than 80% of all the matter we know. It is fundamental to the very fabric of our existence. Its gravitational influence allowed the first stars to form at the dawn of time. It sculpted the cosmos to look the way it does today, and it will continue to influence our future. This new study is the most exciting development in the search for dark matter in decades. We are on the cusp of a revolution in our understanding of reality. As we reach the end of this journey, we want to thank you for watching. This is Space. Please remember to subscribe and leave a comment to let us know if you think dark matter is a particle or something even more mysterious. From the high mountains of Chile to the laboratories in Switzerland, the human mind is on the case. Stay tuned, because we might be just moments away from a total transformation of science. It is a thrill to watch this mystery unfold before our eyes.